my name is Ívar. I'm a control system specialist at Veitur, which is a public utility in Iceland. I've been with Veitur for about 2 years now. Before that, I was studying my master's in electrical engineering at the Technical University of Denmark. I'm here to present my slides, system integration in SCADA, DMS, using IEC CIM. I will give you a quick introduction to my organization, our ADMS product, which is a SCADA product from GE. Then I will talk about the CIM project we are working on at Veitur, why we are interested in the CIM, our CIM journey so far, POC, proof of concept project we have been doing regarding GIS and ADMS integration. And then I will discuss what challenges we see ahead of us, the business case for the project, and finally I will talk a little bit about a smart meter project we are currently working on at Veitur. Veitur is a multi-utility. We operate in Reykjavík, Iceland and the surrounding area. We distribute along with electricity, sewage, cold and hot water. Veitur is a subsidiary of Reykjavík Energy, and as such we have 3 sister companies, one being Reykjavík Fiber Network. There is also On Power. They produce and sell electricity from geothermal power plant along with hydro power, but they are also pumping out hot water at around 80 degrees, which they direct to our district heating network. Veitur also pumps up the hot water at a lower temperature around 60 degrees. But then we also have Carfix. Carfix is a sort of a startup which grew from On Power, but they are dedicated to turning CO2 to basalt rock. They have received a very generous funding from the European Union to scale up their capabilities. But so far they have injected around 63,700 tons of CO2 into basalt rock since 2014. As Veitur is a multi-utility, we have 2 control centers, one dedicated to electric distribution, where we have the SCADA system from GE, and then we have another control center for the water distribution, where they have the ABB system. But our ADMS, it was commissioned at Veitur in 2016. ADMS stands for Advanced Distribution Management System, and our product contains both the SCADA and the DMS. And as you can see from this picture, it was a pretty big step from what we had before. Before we only had the feeders at the primary substations in a digital representation and the real-time operation, and simply the secondary substation was a pin on a whiteboard. But now we have a digital representation of the high and medium voltage, but not the low voltage. But there are many additional benefits with having the ADMS. For example, optimization capabilities, switching advisor helps operators create the work orders, and then it also requires more discipline, as it's harder to make mistakes, and that just makes the safety for our field workers more. But there are some challenges having a digital representation of the medium and high voltage network, and they mainly come in keeping it up to date, as all new equipment is first drawn in the GIS and then it is manually drawn again in the ADMS. So it requires additional manual labor, and you have essentially 2 points of human error when you are inserting into the GIS and then again into the ADMS. So for sure there's a value in automating this process. For those unfamiliar with how what an ADMS looks like, but essentially have a geographic view of all of the secondary substations on the 11 kV, which is the meeting voltage in our case. And then you also have a schematic view of that same equipment, where we connect the SCADA points, if there are any in the secondary substations. And so you have real-time values from the equipment and their positioning. But one of the core functions of the ADMS is to manage the positioning of all switches and breakers in the network. For system integration, well, when we are talking about system integration, you essentially have two systems which are independent and speak two independent languages. And that is why you would need an intermediator to come in between. And that is where the IAC CIM comes in. You would then exchange the data using web services like REST, SOAP. And if you have many systems integrated, then ideally you're using an enterprise service bus, which manages sending and receiving the CIM files between the systems. Also, each system would need an adapter, and that adapter can either be inbuilt, as in the system is already CIM compliant, or you have an external adapter, which takes the data, turns it into CIM, or it receives CIM files and then turns it into the data the system understands. The common information model, it's essentially a formal information model based on the unified modeling language, and it is designed to make integration between systems in the electricity domain easier. And it contains hundreds of classes and relationships, so it is very extensive. The reason we at Veitur are interested in using CIM, it is an international standard, and vendors are always getting more up to speed with having their product CIM compliant. But also very importantly for us, Veitur is a small utility. We simply don't have the resources to generate our own in-house standard. That's why standards such as CIM are very, very important for us to rely on. I personally heard about CIM the first time when I started at Veitur, and it is a pretty steep learning curve. It depends on your background, of course, but if you're new to XML or web services, for example, then there is definitely a lot to cover. The CIM user group homepage also may not give a lot of information for beginners. It was also pretty unclear for me in the beginning if the standard was free or if you needed a paid registration with the CIM user group. And also I had some problems registering my email, and I didn't get much response from the mail. But I got through eventually, and it is in fact free. You just sign up at the page and you download it from there. But if you're just getting started out with CIM, then I would definitely recommend the Common Information Model Primer by EPRI. It's an excellent starting point. The CIM standard itself, it exists in the software Enterprise Architect by Spark Systems. So you would download the CIM standard from the CIM user group website and then import it to Enterprise Architect. But another important concept in a CIM is the CIM profile, which is a subset of the full standard, and it includes all possible custom extensions of the model. As a CIM standard has hundreds of classes and relationships, then for practical reasons, a profile selects a subset of the classes and relationships that you want to use. For a specific application or use case. And as part of the standard, you're also allowed to add your own classes and relationships, and you add these to the profile as an extension. So it's not very unlikely that vendors have made some custom changes to the CIM. And for that reason also, you cannot be expected to create your own profile when you're importing CIM into a system that is already CIM compliant, like our ADMS. But in any case, you should be able to get pretty far when it comes to topology exchange using the profile from NSOE. When it comes to GIS and ADMS integration, I would say there are two main approaches you could take, as we have ArcGIS from S3, because, well, not only do you need to exchange the CIM, but the GIS data needs to also fit the requirements of the ADMS. So even if the CIM is very extensive, it simply can't create data for you. And so, like I mentioned, there are maybe two ways to take. One being using a Small World Electric Office, which is a GIS product from GE, and you then essentially put it in between, and then you end up integrating two systems from the same vendor, and that would streamline the process a little bit. Another option is upgrading your existing GIS to the Utility Network Management extension, or what we just call Utility Network. Essentially, it's an extension on your current GIS, specifically designed for utilities to help them better manage their networks. It is also designed to manage data with the content needy to integrate with ADMS systems. So that is the approach that we are interested in. As of course, when you're trying to do a project like that, you need the GIS team with you 100%. And as a multi-utility, you also need to take an approach that can be sold to all of the utilities, as the GIS provides services to all of the utilities, and make sure that you're not overspending in just one branch. The GIS team leader at our organization had also been looking at the utility network on his own. When it became clear that there is definitely a way forward, we decided to run with that. Just to give you an idea what the utility network looks like, it is essentially a complete digital twin. It defines all interconnectivity between components in the data. Feeders are also displayed under their normal operation, whereas the SCADA is the real-time operation. And then it can also represent all of the necessary components to support CIM. So we did a proof of concept with Similix. They are a software consulting company from Denmark, and they are utility network experts. They also have their own software tools like the Similix SIM adaptor. It is specifically designed to extract data as CIM from the ArcGIS. It also comes with a user-friendly interface, and well, they can adapt it also to the needs of their customers. So we set up the project in these steps. We wanted to see how much work it would take to migrate the data from the utility network, as it has very thorough requirements when it comes to data quality. Similix also have their own migration tool to migrate data to utility network. And then we looked into sending data from the ArcGIS to PowerOn but mainly we use the POC to analyze and research the CIM import capabilities of PowerRun. When it comes to mapping CIM to an ADMS, you are essentially mapping the components. You map the attributes in a CIM to the attributes in ADMS. But as an example, a component can have two geographical representations, whether it has a SCADA point connected to it or not. But then you also need to map the geographical world, as the ADMS has many different worlds. It has a geographic representation, also a schematic representations, and it has its own internal coordinate system. So it needs to know where to place the components in the CIM correctly in the geographic world. And well, we had some problems in our POC getting through this part, but at least vendors could really help their customers out by just creating very thorough and comprehensive guides on how the CIM mapping works on their product. There are certainly going to be some challenges getting the full CIM integration. The system is live. There will always be an intervention into the live system. And the problem is to simply make that as small as possible. Also, no component has an MRID, which stands for the Master Resource ID. MRID is the main identification attribute in the CIM, and each component needs to have an MRID for the system to recognize the component. So, and also when you're doing initial load of the system, you're importing the so-called CIM full feeder files. These files import new components from the feeder head and to all downstream normally open points. And how that will affect those components already in place is uncertain at the moment. The system also uses the CIM difference files for the incremental updates. CIM difference file is some CIM XML. It includes all the changes which are made in the representation on a part of the grid. And for example, if you were to cut the cable to introduce a new substation, then the original cable is then listed as deleted. Two new cables will be listed as new. The substation, including all the equipment, will be listed as new. And the CIM difference file and both includes the backwards differences, as in how it was before, and then forward differences, as in how is it going to become. But I believe it's very likely that the initial load import is the only option, instead of updating the network just incrementally from the start. But it remains to be seen. But if that is the case, then it means that we would have to reconnect all the SCADA points again, and not to mention the schematic world, which needs to be created manually in any case, as a component in the ADMS is unique. But so it's the same component whether it exists in the schematic or geographic world. So you essentially just copy paste the components between the worlds and rearrange them. But if it's a whole network, then that requires a lot of work. So this is how we see the roadmap. It will require approximately 1 year of tensor cleansing for 2 people to get the electric distribution data in a good enough state, so it can be migrated to the utility network. The intention is to create it continuously, so you gradually update the data, and then that data gets fed to the utility network as it then kind of grows in the background. We need to acquire a migration tool also, instead of making something custom. And then in the meantime, we will continue researching the CIM import capabilities of PowerOn, both the mapping and the interface. And yeah, like I mentioned, it remains to be seen if we can continuously load from the utility network while it is being created, or we have to wait for it to be ready and then import it all, but it remains to be seen. And if that's the case, then we just need to be patient for that to be ready. Though I suspect we're going to need all that time to research everything about the CIM interface to get where we want to be. But we see that in late 2022, we could maybe go live with the CIM interface between utility network and the PowerOn. But of course, it's also important to make it clear that the utility network is, of course, simply not a project as a sort of a means to an end for the GIS and ADMS integration. The utility network is an entirely independent project, and it can completely stand on its own. But for us, it's more of an opportunity to partake in that project. And so our requirements are also heard and understood. But the business case for the CIM integration and the utility network, essentially it's not a cost-saving exercise. You of course save some cost in reducing the manual labor needed to manually create the network again in ADMS, but in the full picture that is of course not that much. And instead it is meant to improve our business process and data quality, get us closer to a single source of truth, which is the master data strategy, that data is only collected once and then distributed throughout the organization. But another very big factor for us as well is that the low voltage network is not part of our ADMS. And if we want to get there, then the CIM integration is absolutely necessary. And it is simply only going to become more necessary as since we have a advanced metering infrastructure project which has already been signed. We made a contract with Iskra. They are a smart meter vendor. We are purchasing around 100,000 smart meters for electricity and then 50,000 smart meters for the hot and cold water distribution. The smart meters also have CIM capabilities. They can send us alarms through CIM, and then they will send us data which we can use to help with predictive maintenance, outage management, and average consumption, as an example. So I guess it was only a matter of time until the CIM came to us, and it has really has appeared right now. But this is kind of our near future vision for our CIM integration, where our ADMS is at the core, and since we are already looking at the utility network PowerOn integration, then as we also have the software PSS Incall, which is a simulation software from Siemens, and they also have CIM capabilities for topology exchange, and it's another low-hanging fruit to kind of take that kind of at the same time. But then, yeah, like I mentioned, the smart meters are gonna send us near real-time data and alarms using the CIM. So just to wrap it up, we want to go through with the CIM integration to help us distribute data between systems, between departments, so that we can get the low voltage into the DMS. The smart meters, they are coming and they're going to send a CIM, probably whether we would like it or not. And then we also have the software PSS in-call. This is a CIM-compliant system. And then there are just a lot of opportunities for the future for further integration. For example, with our asset management system. But we see the utility network would be a very good solution for us, especially as a multi-utility. We can move the utility network to the other utilities after we would finish converting the electricity distribution. And like the core benefits, of course, it has this interconnectivity defined in the data. It has inbuilt quality assurance tools where you create your own rules in which components are supposed to be able to connect to each other. It makes the representation more accurate, and that again will just make our ADMS more accurate and safe. And the business case, it is to improve our business processes, our data quality. So we see it as a future-proof strategy, 15 years to 20 years into the future. I'm leaving here a picture of our low voltage monitoring, which we are experimenting. We make do with just keeping it in a schematic for now, but hopefully in the near future we can have SCADA monitoring in the geographical representation as well. Thank you very much.
Thank you so much for watching. I hope you found this video insightful and enjoyable. We post new smart grid related videos every Friday at 12 CET, so please go ahead and subscribe and let colleagues in other departments and peers in other organisations know so that they can benefit too. We welcome your feedback, so if you have any comments or questions, please feel free to post them below. Thanks again and have a great day.